In this video we're going to look at how successive ionisation energies gives evidence that electrons are within shells. Okay, so here's a graph for oxygen. The question has been posed is how does this graph show that oxygen is a group 6 element? Okay, so here I've got the electron configuration for oxygen, 1s2, 2s2, 2p4. Okay, and we've got our data plotted here. It's more of an idealized plot than physical data, but the trend looks reasonable. So remember, when we're taking out electrons from an atom, we start off with the highest energy electron first. Okay, so we will be we're taking out the 2p4 electron here, and then the next one we'll take the 2p3, then the 2p2, then the 2p1. Okay, it's becoming increasingly difficult to remove these electrons because you're having to overcome the attraction between the electron and the positive nucleus. Okay, so now we're moving now to the 2s. So we take the 2s2 electron out and then the 2s1. Okay, so all of these 6 electrons are within the same shell, the second shell. Then when we come to take the 7th electron, well, that 7th electron is the 1s2, and then finally the 8th electron is the 1s1. So why is there a big jump? Well, there's a big jump because the first shell is much closer to the nucleus than the second shell, so therefore these electrons are experiencing a much greater attraction to the nucleus than what the electrons down here were experiencing. And so that really just gives us our evidence of 4 shells. So if you are being asked to identify what group an element is in, then you always look for the biggest jump in, or a very large jump in the ionisation energy, and then you work backwards and say, well, there was 1, 2, 3, 4, 5, 6 electrons in before the big jump, so that means there were 6 electrons in the outer shell. So therefore, 6 electrons in the outer shell, so therefore that means this is in group 6. Okay. Thanks for watching.